In this video, I'm going to be showing you how to name alcohols according to IUPAC nomenclature. Now, the first example here would be to name this compound. Okay, so if we're to name this compound, we follow the rules, the general rules of naming alkanes, okay? The difference here is the suffix is going to be all instead of in. For example, when you're talking about propane, for example, now instead of the E here, what you would then have for alcohol is OL, okay? So you won't have the E, you would then have OL as the suffix. So that's the major difference. All the other rules apply. And if you are yet to watch my video on naming of alkane, you can go ahead and watch that. That would teach you how to name alkanes. With that, that's like the basic step you need, and that will help you to understand what I'm talking about here in IUPAC nomenclature of alcohol. All right, so now the first thing to do here is to count the number of carbons starting from here. Now, why am I starting from here? I'm starting because that will give this OH a lower number. The all is going to give it a lower number. If we start from here, it's going to make it 3, and that is higher than 1, right? So we're starting from here to number. Now we have 3 carbons, and 3 carbons in chemistry is represented as prop. So because it is 3, it will be propane, okay, without the E. Propane without the E, it will then be propane. Because the carbon bearing the OH is carbon 1, it will then be 1-or. Okay, so it will be propane 1-or. In some textbooks, you will see them say 1-propanol. Okay. All right, so this is not wrong, but this is like the old way of naming it. Now, IUPAC has given a new directive that the number should be closer to what they are representing. So the all is what this number is representing, so it should be closer. So this is a more accepted way of naming, but that doesn't mean this is not correct. It's also correct, but to be on the safer side, please follow this first one when naming, okay? Because that's the latest development, propane 1-or. So that's how you can name this first compound. Now let's go to the next example. Now, if I were to name this, we'll start from here, right? Because that's the one that is closer to OH. So that will be 1, 2, 3, and then 4. The longest chain has to be considered, no matter what. Now, see, normally maybe you could have thought that this is an attached group, but it's not, because if you stop here, you're not considering this other carbon, and that's the longest chain. So you need to consider the longest chain when you are naming. So for this compound, the name would be, since it's 4, but represents 4, so it will be butane 1-or. Okay, next example I have is this. So now, if we start from here, this will be 4. If we start from here, this will be 2. So the counting will start from here. And this is the longest chain, okay? So it means that these ones here are the attached group. Now, if I want to name this compound, we start with the attached group. So we start with 3,4-dimethyl. Now, these are methyl groups, and it's 2 of them. So that is why I use the word dimethyl. And the longest chain is 5-pentane. Pent represents 5. So it will be pentane. The OH is attached to the second carbon. So it will be 2-ol in this case. So the name is 3,4-dimethyl pentane 2-ol. Okay. All right. The next example is this. Now, this is a cyclopentane. If you count the side, this is 1, 2, 3, 4, and 5. So that's pent representing 5, but because it's in cyclic form, it will be called cyclopentane. All right, so if we are to count, we'll actually start from here because that's where the OH group is attached, okay? So this will be a 1. Now we have an attached group. This is CH3, okay? In a line diagram is represented as a stroke. So it means you have 1 methyl cyclopentane 1-O. Okay, so this is how you name this compound. All right, another example would be dihydric alcohol, the ones that have 2 OH in them. So you have all right, now look at this compound. It has OH here and OH here, okay? So we'd start counting from, we can start from here or here. It will give the same number. This is 1, 2, 3. This is 1, 2, 3. So it doesn't really matter where you start from, okay? So if we start from here, this will be 1, 2, 3. And on the second carbon, you have an ethyl group. On the third carbon, you have a methyl group. Now, met and then ethyl, methyl and ethyl. Now, M and E, you have to then put it according to how they appear in alphabetical order. Okay, so E comes first before M, so it means you're starting with the ethyl group. So the name of this compound will be 2-ethyl, then 3-methyl, and you have 2 different alcohols. So the way you name this will be different. 2-ethyl, 3-ethyl, you name the cyclopentane fully. Cyclopentane full, then you say 1,3-diol. Okay, so this is how you name diols, or what we call dihydric alcohols. You don't name it the way you do monohydric alcohols. Monohydric alcohols are the ones that have just one OH attached. So in this case, you give it a full name and then you name based on where the alcohols are attached, the OH groups are attached. Okay, so this is how this is done. All right, so for this one, you can see here too that there is 2 OH groups. Okay, so all you just have to do is number. I'm going to start from here to be 1, 2, and then 3. So this 3 is a propane. So propane, then you say 1,2-diol. So that's the name, propane 1,2-diol. So you name the alkane full, and then you represent the numbers of the carbon where the OH is attached, and then depending on the number of OH attached, if it is 3, it will be triol. If it is 2, it will be diol. All right, let's do 1 for diol. So if we're to name this compound, this will be 1, 2, 3, right? Still propane. So you say propane 1, 2, 3 triol, because it's 3 of them. Okay, so this is how you can name alcohols when they are in their monohydric form, their dihydric form, or trihydric form. Okay.